7.5 starts to talk about these new phrases, angle of elevation and angle of depression. These you'll see in word problems, so let me just explain what they mean. If you're looking straight ahead and then you all of a sudden decide to look up, say at a plane, okay, the angle that you tilt your head up, that's called the angle of elevation. What if you were looking straight ahead and you all of a sudden look at, I don't know, a penny on the ground or something like that, or a piece of gum? The angle that you tilt your head down, that's the angle of depression. Okay, so elevate, you're looking upwards. Depression's kind of like you feel down, so you're looking down. All right. Now this is a word problem where it uses this phrase. While standing exactly halfway between two tall trees, Navneet spots a blue jay at the top of one tree and a cardinal at the top of the other, as shown. From Navneet's point of view, the angles of elevation to the blue jay and to the cardinal are 60 degrees and 50 degrees respectively. The trees are 40 meters apart, and if Navneet is 1.5 meters tall, find the height of each tree to the nearest tenth of a meter. Okay, the very first thing I'm going to do is I'm going to start putting all of my numbers into the diagram. Okay, and I'm going to start with those angles. So she's looking straight ahead, and then she has an angle of elevation. She's going to look upwards at 60 degrees. So she's going to look up to the blue jay at 60 degrees. Now that word respectively just means that whatever they mention first, that goes with the first angle. Okay, and whatever they mention second, that goes with the second angle. So she's going to look straight ahead. And again, she's going to look upwards towards the cardinal at a 50-degree angle. Okay, I think you're starting to see the two triangles here. If I just draw this straight line and the 90 degrees, because I'm assuming these trees are straight up and down, they're not crooked. Okay, we get our two triangles. These triangles only have two numbers with them. Let's see what else they actually tell us. So she's standing halfway in between the two trees. That means that this is 20 meters and that's 20 meters because we had a total of 40 meters. There's one last number and that's her height. We'll probably use that later on. I'm just going to put right here that she was 1.5 meters tall. Okay. What I'm going to do is I'm going to scroll down, and as you can see, I've already drawn both of the triangles separately. I'm going to take a look at each of the triangles on its own. All right, now the X represents the height of the tree from her vision line all the way to where the blue jay is. Let's look for X. Now my eye is going to be drawn in this corner because that's where the 60 degrees is, which means this side is my opposite. My hypotenuse is over here, and this is my adjacent. It looks like I have an X for my opposite and a 20 for my adjacent, but nothing for my hypotenuse, so I'm just going to get rid of that. That's probably not going to help me out. Okay, now opposite and adjacent, I'm thinking of SOHCAHTOA, and that's just TOA. Okay, so there's my O and my A. That means that I'm going to be using tan. So tan theta is opposite over adjacent. I'm going to start filling it in. So tan 60 degrees is opposite, which was my X, over 20, which was my adjacent. Okay, and to solve this, I'm going to put a 1 underneath and cross multiply. X times 1 is X. 20 times tan 60. I'm just going to put that into my calculator. Okay, so I'm getting 34.641 and so on. And let's just take a look at how they asked us to round. Okay, so the nearest tenth, that's 1 decimal place. Okay, which means that 4 is not going to change to 6. It's going to stay a 6. There we go. And I believe they said meters. Since I rounded, I cut off some of the numbers. I'm just going to put an approximation dot. Okay. All right, that means if I go back up to my diagram, this part right here, from here to here, that's 34.6 meters. Okay. We're going to do the exact same thing again just to find out what this length is. Okay. Eyeball goes here because that's where the 50 degrees is. This is my opposite, hypotenuse, and adjacent. And again, there's nothing for my hypotenuse, so I'm going to get rid of it. And opposite and adjacent again, well, that's just tan once more. Okay, so tan theta is opposite over adjacent, and my angle is 50 degrees this time. Opposite is my y. I didn't put x because I already found x. We need to use a different letter. Okay, so y. And over 20, which was my adjacent. Cross multiply. 1 times y is y. Tan 50 times 20. Okay, 20 tan 50 is 23 point, and then 1 decimal place would be 8, because that 3 is not big enough to change the 8 meters. And again, around it. Okay, so just going to scroll back up again. We found out that this was 23.8. Now you're probably going to tell me, well, that's not the entire height of the tree. I mean, we still have the stem, we still have the trunk of the tree, right? Anything from this point to this point, well, that's where her height comes in. Because again, this was her sight line. So 1.5, this is also 1.5. I'm going to add those onto the blue and the red heights of the trees. And that should give us our total height. Okay, so height of tree number 1 equals 34.6 plus 1.5, and that's approximated because the 34.6 was approximated. 34.6 plus 1.5, I'm getting 36.1. So that's the first tree. Now the second tree. Of tree number 2 was 23.8 plus 1.5. 23.8 plus 1.5. 25.3. And again, approximated because the 23.8 was originally approximated. And since it's a word problem, always end off with a therefore. The height of the trees I guess I should say the heights of the trees are 36.1 meters and 25.3 meters.